Good day, class. This is day 2 of our lesson in solving trigonometric equations. So before we start, let me have the following reminders. First, always check and use the given interval. Second is you have to factor correctly. Yes, you will need your knowledge in factoring in this topic. And third, when you see expressions such as sine squared theta, this means sine theta squared. Okay, so let's start with example number 1. Given the interval, theta is greater than 0 degrees but is less than or equal to 360 degrees, find the exact solution to the equation 7 cosine theta plus 13 equals 6 cosine theta plus 12. Okay, so here, so that you don't get confused, I will let the function cosine theta be equal to the variable a. Okay, and then my equation will become 7a plus 13 is equal to 6a plus 12. And then we'll just solve for a. So I'll have 7a minus 6a is equal to 12 minus 13. So my a is equal to negative 1. Okay, after getting the value of a, you substitute back cosine theta. So I'll have cosine theta is equal to negative 1. Okay, now you recall our lesson about special angles or quadrantal angles. So what value of theta will give you the value of cosine, which is negative 1? Okay, so here we have the quadrantal angles, right? So our theta here is equal to, very good, 180 degrees. Okay, so 180 degrees will be our answer for question number 1. Okay, now, how will you check if your answer is correct? Okay, so let's do the checking. You just substitute theta in the given equation. So 7 cosine 180 plus 13, will it be equal to 6 cosine of 180 degrees plus 12? Okay, so I'll have 7 cosine 180 is negative 1 plus 13, will it be equal to 6 cosine 180 is negative 1 plus 12? So I'll have negative 7 plus 13, is it equal to negative 6 plus 12? Okay, negative 7 plus 13 is 6, is equal to 6. Okay, therefore our answer is correct. Example number 2, use the interval theta is greater than or equal to 0 degrees but is less than 360 degrees. So we have the equation for tangent theta minus 5 equals negative of the quantity 4 minus 3 tangent theta. Okay, so here we simplify first our equation. Okay, so I'll have 4 tangent theta minus 5 is equal to negative 4, and then negative times negative is positive, so positive 3 tangent theta. Okay, so that I don't get confused, we just let tangent theta be equal to variable a. You may use any variable. So you'll have 4a minus 5 is equal to negative 4 plus 3a. And then you just solve for a. So 4a minus 3a is equal to negative 4 plus 5. So A is equal to 1. Okay. After solving for A, you have to substitute back tangent theta. Okay, so tangent theta is equal to 1. Now, you determine the value of theta that will make your tangent equal to 1. Okay, so if you will look at the table for the 30, 60, 45 degrees, tangent there has a value of 1 when the angle is 45 degrees. Okay, now, since it is positive 1, okay, we determine the quadrant where tangent is positive. Okay, so tangent is positive in quadrants 1 and 3. Okay, so we get the value of our angle, our 45 degree angle in quadrants 1 and 3. Okay, so that would be 45 degrees and 225 degrees. So this will be our solution set. Okay, you may check your answer by substituting them in the given equation. Okay, so this is example number 2. Example number 3, use the interval theta is greater than 0 degrees and less than 360 degrees. The given equation is 4 sine squared theta is equal to 3. Okay, so the first thing that I have to do is I will let A be equal to sine theta. Okay, take note guys that sine squared theta means sine theta that is being squared. Okay, so my equation will become 4a squared is equal to 3. And then I'll just solve for a. So I divide both sides by 4. So I'll be left with a squared is equal to 3 over 4. Now, how do we solve for a? Okay, we get the square root since it is squared. So that the squared will be cancelled. So my a will become positive and negative square root of 3 over 4, which can be written as square root of 3 over square root of 4. So that would be square root of 3 over square root of 4 is 2. Okay, so this is my a. Now, after getting a, you have to substitute back sine theta. Okay, so I'll have sine theta is equal to positive and negative square root of 3 over 2. Now, you determine it in what special angle is sine theta square root of 3 over 2. Very good. So, our theta will be 60 degrees. Okay, now, since the sign here are both positive or negative, okay, it means we will get the angles that have a reference of 60 degrees in all quadrants. Okay, in all quadrants because it's positive and negative. So 60 degrees in quadrant 1 is 60. 60 degrees in quadrant 2 is 120. In quadrant 3 is 240. And in quadrant 4 is 300 degrees. Okay, so this will be our solution set. Okay, take note also that the given angles are still included in the given interval. Okay, because they are between 0 and 360. Example number 4. Use theta is greater than equal to 0 and less than 2 pi. For the given equation, 2 cos square theta plus 3 cosine theta plus 1 equals 0. So take note that our answer should be in radian form. Okay, so let's start. Again, we may start by letting a certain variable be equal to our trigo function. So again, I will let a be equal to cosine theta. So my equation now will become 2a squared plus 3a plus 1 is equal to 0. Okay, and then you have to factor the given quadratic equation. So that would be 2a, then this is a, plus 1 and plus 1 equals 0. So 2a plus 1 is equal to 0. So my 2a is equal to negative 1, or a is equal to negative 1 half. And then the other side, or the other factor, is a plus 1 equals 0. So a is equal to negative 1. So after getting this, we just substitute back cosine theta. So cosine theta is equal to negative 1 half. Then the other one is cosine theta is equal to negative 1. Okay, so after doing that, I'll just rewrite the first one. Cosine theta is equal to negative 1 half. Okay, so you determine the angle that will make theta equal to 1 half. So you go back to your special angles. Okay, so cosine is 1 half at 60 degrees. Okay, and then it is negative. Cosine is negative in quadrants 2 and 3. Okay, now we have to get our angle in radian form. Okay, 60 degrees. So we know that our angle in radian form is 60 degrees if its denominator is 3. Okay, so 30 degrees in quadrant 2. Okay, let us recall our technique. Okay, in quadrant 2, we use denominator minus 1. In quadrant 3, we use denominator plus 1. Okay, so our answer will become 3 minus 1 is 2. And then 3 plus 1 is 4. Okay, so this will be our answer for the first one. And then we will do the second part. So cosine theta is equal to negative 1. So we know that cosine is negative 1 in the quadrantal angle, okay, which is 180 degrees. And 180 degrees in radian is pi. Okay, and then we just write our final answer. We have to combine the two angles. Okay, so I'll start with 2 pi over 3, and then pi, and then 4 pi over 3. Okay, so this will be my solution set. Take note that when you write your final answers in the solution set, you have to write them from the least value to the greatest value. Okay, so this is example number 4. You may check your answer by substituting them in the given equation. Okay, question number 5. Use theta that is greater than equal to 0 but is less than or equal to 2 pi. So the given equation is cosecant squared theta is equal to 2. Okay, so again, I will let a be equal to cosecant theta. So my equation will become a squared is equal to 2. Okay, so I can solve for my a by getting the square root of both sides. Okay, so my a will become positive and negative square root of 2. So after getting that, we have to bring back cosecant theta or substitute back cosecant theta. So cosecant theta is equal to positive or negative square root of 2. And then you go back to your to our special angles, the table for the special angle. So there you will get that, or you will know that cosecant has a value of square root of 2 when our angle is 45 degrees. Okay, now since the given is in positive or negative, so it means it's present in all the quadrants. Okay, in quadrants 1 to 4. Okay, so what will be the value of our theta? Okay, so that would be 45 degrees. Okay, so 45 degrees, we know that our denominator should be 4. Pi over 4 is 45 degrees. Now, in all quadrants. Okay, so we have to recall the technique that we use. Okay, so if it's 45, we know that all our denominators are 4. Okay, and then we just use you recall the table. Okay, I'll just write down the table here. Okay, so this is quadrant 2. For quadrant 2, we use denominator minus 1. Here in quadrant 3 is denominator plus 1. In quadrant 4 is twice the denominator minus 1. Okay, since our denominator is 4, 4 minus 1 is 3. 4 plus 1 is 5, and 4 times 2 minus 1 is 7. So our solution set will now be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so this will be our final answer. Again, you may substitute them in the given equation for you to check if they are correct. So this is example number 5. Okay, example number 6. We use theta that is greater than or equal to 0 degrees but is less than 360 degrees. And then the given equation is cosine theta, sine theta minus sine theta is equal to 0. So if you will notice in our example, we have two trigo functions. Okay, now, if you are familiar with substitution, we have to substitute one of them as a certain variable. Okay, since we have two functions, I can substitute one using a. So let's say I will let a be equal to my cosine theta and b will be my sine theta. Okay, by the way guys, if you are familiar with just factoring using the trigo functions, you may do so. Okay, if you don't want to substitute them with a certain variable, you may do so. Okay, so this will become a, and then sine is b. So ab minus sine is b is equal to 0. Okay, then I have a common factor which is b. So I'll have a minus 1 is equal to 0. So I'll have b is equal to 0, and the other one is a minus 1 is equal to 0. So solving for a, my a is equal to 1. And then I will substitute back my b. Okay, So I know that my B is sine. So sine theta is equal to 0. And then the other one is A. I know that my A is equal to cosine. So cosine theta is equal to 1. Okay, now let us identify. In what angle or angles is theta equal to 1? Equal to 0. Okay, very good. So sine is 0 at 0 degrees, 180 degrees, and 360 degrees. Okay, now, but if you look at the given interval, we just have theta equal to 0. Okay, so we cannot have 360. Okay, now let's go to the second part. So cosine theta is equal to 1. So in what angle is cosine equal to 1? Okay, so that would be in 0 and 360 degrees. But then 360 is not included in the interval. So our final answer will be just 0 and 180 degrees. Okay, so this will be our answer. Number 6, again, you may substitute it in the given equation to check. Okay, example number 7. So we just use the interval theta between 0 and 2 pi, inclusive of 0 and 2 pi. And then the given equation cosine theta is equal to 2 sine theta cosine theta. Okay, now let's try solving this without substituting a certain variable for them. Okay, so let's just practice that. So this is equal to cosine theta. I'll just transfer 2 sine theta on the other side. So 2 sine theta cosine theta is equal to 0. And then you will see the common factors, which is cosine theta. So you factor out cosine theta. So that would be 1 minus 2 sine theta is equal to 0. Okay, since it is factored already, we may equate each factor to 0. So cosine theta is equal to 0. And the other factor is 1 minus 2 sine theta is equal to 0. Then I'll just solve for sine. So negative 2 sine theta is equal to negative 1. Then I divide both sides by negative 2. So that I will be left with just sine theta, which is equal to positive 1/2. Okay, now let us get the values. The first one is cosine theta is equal to 0. So in what angle is theta equal to 0? Okay, so cosine is 0 along the y-axis. So that would be pi over 2 and 3 pi over 2. You recall your quadrantal angles. Okay, so that would be pi over 2 and 3 pi over 2, or 90 and 270 degrees. Okay, now let's go to the other one, which is sine theta is equal to 1/2. Okay, now you go to our special angles. Sine is 1/2 at 30 degrees. Okay, and it is positive in quadrants 1 and 2. Okay, now for the sine, okay, you recall the cast rule. Okay, so sine is positive in quadrant 1 and quadrant 2. Now, what is 30 degrees in quadrant 1? So that would be 30 degrees. 30 degrees in quadrant 2 is 150 degrees. Then you have to have our answers in radian form. So 30 degrees in radian form is pi over 6. In quadrant 2, that would be 5 pi over 6. Recall, quadrant 2 is denominator minus 1. So 6 minus 1 is 5. And then we just make a summary of our answers. Okay, so the least is pi over 6. Then pi over 2. Followed by 5 pi over 6. And 3 pi over 2. Okay, so this is our answer for question number 7.